Welcome students. So in this session we will be discussing about the bit oriented or bit manipulation or Boolean instructions that is supported by 8051 McDonald. So why we call these instructions that a bit oriented or a Boolean instruction is because here the instructions are more or less, as we have seen earlier, it is more or less it performs the same operations which is being performed by the data transfer or the logical instruction set, but here the source and operands or the final impact is only on a single bit rather than on a group of bits, or rather than on a byte of data. So here the operation is basically performed between two bits and the resultant is updated on a single bit. Hence we call all these instructions under this instruction set as a Boolean instruction. Okay, so let's look to the basic instruction. First one is a set bit, which means it is going to, so this instruction set bit is used to make the or set the value of the bit specified in this instruction equal to 1. Okay, so for this instruction there is no specific addressing mode because we doesn't have any addressing mode where a mode that is used to describe a 1 bit operand in the instruction. Okay, so there is no addressing modes for the instructions that is categorized under the Boolean instruction set or the bit oriented or manipulation group. Okay, so set bit means the bit specified in the instruction is been set. There are two different categories, that is set C where the carry flag is set equal to 1. So this is used when the programmer needs to set the carry flag by his wish rather than setting the carry flag automatically as part of an arithmetic or other logical instructions. Okay, then we have set bit. So here set bit means the bit that is specified in instruction is made 1, and this bit can be a bit location, or it can be a bit addressable RAM location, or it can be any of the bits of the bit addressable SFRs. Okay, we have a large number of special function registers in 8051, and there are several registers where each of the bits can be configured by the programmer. So in those cases, if I need to make one of the bit of a special function register as 1, then I can make use of this instruction set bit. Then the opposite of setting, that is clear the specified bit, I have clear bit. So one of the commonly used one is clear C where the carry flag is cleared by the programmer, and one is clear bit where one of the bits of the bit addressable RAM or any of the bit addressable SFR is cleared. Okay, then we have the complement where the bit specified in the instruction is logically noted. Okay, logical not operation is performed and the value is updated to that same bit itself. So CPLC means the current value of the carry flag is complemented and it is updated to the carry flag. And CPL bit means this bit specified, as I told earlier, it can be either a bit addressable RAM location, or it can be any of the bit addressable SFRs. Okay, the special function, the bit of the bit addressable SFR, which is being complemented and updated. Okay, then we have all the previous one was just the direct applications. Now we have the move bit comma bit means the bit specified. So we have two different formats. The first one, move C comma bit, means the bit specified in instruction, the source bit is copied to the carry flag, the content. Okay, so if I have a bit addressable RAM locations value 1 and the carry flag is 0, and I need to make the carry flag 1, or I need to copy the content of that bit addressable RAM location to the carry flag, then I can use move C comma bit for copying that value from that particular location to the carry flag. Or else if I need to save the content of the carry flag to some bit addressable RAM location, or I need to copy this, if the carry flag equal to 1, I need to make one of the SFR a bit of the SFR as 1, then I can go for the second configuration, that is move bit comma C, where the content of the carry flag is updated to the bit specified in the instruction. Okay, similarly if I need to perform some sort of logical operations between the carry flag and some of the bit addressable locations to see whether it is equal or not. Okay, so in that cases I can go for ANLC comma bit, where the bit specified is logically noted with the or the logical AND operation between the bit specified in the instruction and the carry flag is taken place and the resultant is updated to the carry flag. So we have two different combinations, where the first one is the logical AND operation between the carry flag and the complement version of the bit specified. Okay, and the second one is the logical AND operation between the carry flag and the bit specified directly. And we have the other, we never go for the or L. In this case it's sufficient that we can go for the logical AND alone. So we have the next one is the JB bit comma address. So here in the previous instructions we have seen that the instructions were performing on 2 bits and it is just updating some results. Now based on the value of some of the bits, if I need to control the program flow, I can use this JB bit comma address, where the bit status is being checked, and if the bit specified in the instruction is equal to 1, then the program logic is shifted to some other address, and where the address is specified in the instruction. Okay, so in this case the address will be in the format of a relative target address. That is it can only be within the 256 bytes, because the relative address which is specified in this particular instruction can be an 8-bit address, can be an 8-bit only. So the maximum combination is 256 combinations. Okay, so from the current position the program can be shifted, or the control can be shifted to some 256 bytes long if the bit specified in this instruction is set is equal to 1. So it checks the status of the bit, and if it is 1, if it is satisfied, it is going to transfer the program logic. And the opposite of that, if the bit is not equal to 1, if the bit value is just 0, in that case if we need to perform that jumping action, I can go for JNB bit comma address. And in these two cases, JB bit comma address and JNB bit comma address, we can see that the bit value is monitored. If it is 1 or if it is 0, corresponding to the instruction the operations are taking place, but the value of the bit is not updated. Okay, so if I need to update that particular value, I can go for the next case, that is JBC bit comma address, where it checks whether the bit specified in the instruction is set or not. Okay, if it is equal to 1 or if it is set as 1, then the jumping action occurs, and after that the bit value is cleared. Okay, so that we can have a single time execution. Okay, if the bit is equal to 1, then I can jump to the location, and after that I can clear it, so that if again if that bit is been checked, it is not getting false triggered. Okay, but in the previous cases there may be chance that initially due to some actions a bit has been set, but that action is not repeating, and there is no chance of the setting that bit again and again. But since it was not cleared, that action is going to repeat again and again. Okay, so these are some of the instructions that is present in the bit oriented or bit manipulation or the Boolean instruction set of 8051. And we have a few instructions which is very commonly used, and which serves as the basic instructions of the instruction set of 8051 microcontroller under this particular Boolean instruction set category. Okay, now we have the branching instruction set category, which we will be discussing in the next session. Thank you.